You're watching Infosec Bytes, a crash course in information security for journalists. We're based at the Centre for Investigative Journalism in London and supported by the Logan Foundation. This is a tutorial about how to protect your data and how to safely erase it. This video is provided for information only. It cannot replace the advice of a trained security professional. If lives or safety depend on your security, please seek the advice of an expert. The Centre for Investigative Journalism is a pioneer in providing expert information security training services to journalists and journalistic institutions. To consult with an expert through the CIJ, or to arrange a CIJ training session, contact the address on screen. In recent years, the concept of encryption and information security has entered the zeitgeist a little. There are hundreds of stories a year about new encryption apps and government hostility to them. But most of the time the focus is on apps for using encryption to communicate over the internet, or on tools like Tor, which allow anonymous browsing. Protecting your communications is important, but information security involves much more than that. For investigative journalists, an arguably even more important topic, but one which receives much less attention, is how to handle sensitive data using computers. This includes how to store sensitive data and how to erase it. In this tutorial, we're going to give a general overview of approaches to handling data, erasing data, and using encryption to protect data. To follow up, we're including a range of tutorials showing how to use various different software tools to erase or encrypt data on Windows or Mac. Click or tap on the pop-up message to skip to one of those tutorials, or keep watching if you would like to know more. Modern operating systems make handling data easy. You can copy and move files simply by dragging and dropping, and discard them simply by dragging them to your trash or right-clicking and deleting. Regular computer users normally work with a range of storage media, such as internal hard drives or SSD drives, and removable hard drives, USB flash drives, or increasingly tiny memory cards. It's geared towards convenience and ease of use, and this encourages us to take a carefree approach to handling data, throwing data around from one place to another without worrying about the consequences. But if you're an investigative journalist, you will probably have to handle sensitive data at some point. Sensitive data might include information about your journalistic sources, or perhaps information which needs to be vetted to protect innocent people, or even classified information. When handling such data, it becomes important to make sure it does not fall into the wrong hands. And as soon as you're in this position, the carefree approach to copying and moving data around starts to look very problematic. As a way into this, let's look at the problem of data remnants. Anyone who uses Windows or Mac OS knows how to delete data, right? It's trivial. It's one of the most basic things you learn how to do on a computer. Wrong. Normally, when you delete a file, you drag it to the trash or the recycle bin. And most people know that doesn't mean it's gone forever. It's still in the trash and can still be recovered. The way to remove it properly is to empty the trash. But most people don't know that even when you empty the trash, it's still there. You just can't see it anymore. It is still possible to recover the files or parts of them using forensic techniques and data recovery software. Truly erasing data is actually a hard problem in computer science. To understand why, we need to think about how data is stored. We'll simplify it a little bit, but this is the basic idea. Data is stored as a pattern of ones and zeros. A hard drive is like a slate on which your computer can write and read those ones and zeros, thereby storing your files. When your drive is new, it's blank, so if you could see the ones and zeros, it would look like this. And when you start copying files to it, those files are rapidly written onto the drive as a block of ones and zeros. All of your files, whether Word documents or PDFs or music or videos, are written in the same way. Files are just blocks of ones and zeros. Larger files take up more space than smaller files. The computer also has to remember where existing files are stored so that it can avoid writing new files over the old ones. Imagine every time you copied a new file to your drive, the computer wrote the new file, in ones and zeros, over the ones and zeros of files that were already there. The older file would be corrupted, and you would lose data. In order to prevent this, the computer remembers where on the physical disk it has written every file, and remembers not to write data on spaces that already contain files. Of course, none of this is how you normally experience files. You normally experience them as a set of hierarchically organized files and folders that you can navigate through using Finder or Windows File Explorer. But all of this is just a metaphor to make it easier to interact with the data. In reality, every file you see in your File Explorer or Finder corresponds to a sequence of ones and zeros on your physical hard drive. Now, what happens when we delete a file in our operating system? On the hard drive, all that happens is the computer now marks the space the file used to occupy as free. The computer sees the space as free and can write new data over it. But until the computer does actually write new data there, the ones and zeros that made up the original file stay in place, like a kind of ghost file. So, if you know how to, you can scan all the ones and zeros on the hard drive, looking for regular patterns of ones and zeros that look like Word documents or PDFs or any other kind of file. And if you find those patterns, you've found the ghost file, and you can now recover it. The files are only truly gone when the computer finally gets around to writing new files over the old space. And on modern hard drives, with terabytes of space available, that might not actually happen for years. Worse still, even if it does, only parts of the data might be overwritten. So while the whole file might not be recoverable, fragments of the file could be, and that can still contain sensitive information. It's easy to see why all of this leads to issues. It turns out that data is actually very hard to get rid of. Even when you delete data off your computer or your storage media, it's very hard to be certain it's really gone. So, what can be done? We're going to run over some things you can do to handle your data in a more secure way. The first thing to remember is that prevention is better than cure. The first precaution you can take is never to handle sensitive data. If you don't have sensitive data, you don't have to worry about protecting it or getting rid of it. This might not be completely practical if you were an investigative journalist, but it is still worth remembering as a modern-day version of don't write anything down that you don't want anyone to read. So that's the first precaution you can take. The second is a preemptive measure. Encrypt everything. You may be familiar with the use of encryption to communicate with other people over the internet, but there is an even more basic use for encryption, scrambling your own data so that nobody can access it but you. When you encrypt your data, the data is scrambled using a secret passphrase of your choosing. This means that the data, the ones and zeros as they are written onto the physical hard drive, are encoded so that they are indistinguishable from a random assortment of ones and zeros. Their patterns are unrecognizable and they cannot be read, except by the person with the passphrase, you. Encryption of data can be done in a number of ways. Many apps allow you to encrypt individual files. However, if you do that, the file will also have touched your drive in an unencrypted form, so this still runs the risk of leaving traces on your drive. But there is another form of encryption called full disk encryption, which applies the encryption process to the whole drive. Full disk encryption can be done with removable hard drives, USB flash drives, memory cards, your smartphone, or the native hard drives in your Mac or Windows computer. It's a bit like placing a lock on the drive so that only you can open it with a passphrase. Encryption won't help you if someone takes your computer off you while it's powered on, or while you have an encrypted drive connected to your computer and unlocked, because then they could just access it as you were doing. But it does mean that once your computer is powered off and your encrypted media are locked and disconnected from the computer, nobody can possibly access your data without your passphrase. Encryption is also only as strong as your passphrase. So if you're going to use encryption, you should use a very good passphrase for each device you encrypt. Creating a secure passphrase is an important skill set, and we don't have time to cover it here, but keep an eye out for a future Infosec Bytes video explaining how to create good passphrases. In the meantime, have a look in the description below this video for a link to a guide that will help you out. It's good to encrypt your drive before you use it for anything else, because this means that whenever the computer is writing data to the drive, the data is always already encrypted. No unencrypted data ever touches the physical hard drive, and therefore it cannot leave its traces there. So if you use full disk encryption on a hard drive from the moment you start using it, even forensic analysis cannot recover data from it unless you give up your passphrase. However, you should know that if you do give up your passphrase, once the drive is decrypted, it is as if it was never encrypted in the first place. So if you do give up your passphrase, files you insecurely deleted on the encrypted volume could be recovered using forensic analysis. So perhaps, even though you should use encryption as much as possible, you still need to take a further precaution, which brings us to the next section, on securely erasing data. Let's say it's too late for encryption. You've already been working with sensitive files, and they are on your drive, and your drive is not encrypted. Or maybe it is, but someone has your passphrase. You want to erase these files securely. How do you do this? In order to properly erase that data, you have to do more than use your OS built-in delete function. You have to do more than merely marking the space the file occupies as free, because, as we saw before, that leaves a ghost file. To truly erase that data, you also need to purge the ghost file. And you do this by deliberately writing lots of new random ones and zeros over the original ones and zeros. Random data over old data, eventually making it unrecoverable. There are three basic approaches you can take to this. The first is overwriting only the file or files you want to erase. The second is overwriting all of the free space on your drive. The third is overwriting the entire hard disk, completely wiping it and making any data on it unrecoverable. We will discuss each of these in turn. The most basic and quickest way to securely erase data is to overwrite only the files you want to erase. Most secure erasure-free software tools offer you a way to do this, and it's very intuitive and is almost like insecure deletion. You can click and then choose to securely erase, and this happens while you watch, and then the file disappears. But you can't do this anymore if you've already insecurely deleted the file. That is, if you already put it in the trash and then emptied the trash. You may have already been working on lots of sensitive files and insecurely deleted them, and now the data resides in the free space of your hard drive, and there is no way to individually securely overwrite each of them. To cater to this, most secure erase tools offer you an option to overwrite all of the free space on your drive. Although this takes a longer time to do, it completely cleans out any data from deleted files still hanging around in the free space. In other words, it gets rid of all your ghost files at once. But sometimes it's hard to know what to securely erase. For instance, lots of modern software keeps logs of the names of files you work with, or even makes backup versions of the files you are working on. All of this is often saved in obscure parts of your hard drive so that you don't even know where to look. So you might erase the sensitive files you were working on, but records or traces of the sensitive information in them might have been left all over the drive. Simply erasing the free space isn't enough. In this case, you may want to securely erase your entire hard drive, overwriting the entire drive with random data, making any and all data on it completely unrecoverable. This can be done with removable drives and with the internal drive in your computer. Our tutorials show how to perform each of these tasks with free software tools. There are a few important warnings that you should keep in mind when you're securely erasing files. Firstly, overwriting once may not be enough. Computer scientists in the field of data remnants have argued that it might be possible to recover bits of data even after a single overwrite using electron microscopy. This is a controversial claim in the science of computers, and not everyone agrees with it, but it's important that you know about it. To counter this, it is recommended that you perform multiple passes, multiple overwrites of the data. There are a range of different recommendations for how many times you should overwrite the data to make sure it's gone. Some of these recommendations are made by individual computer scientists, such as Peter Gutmann, or security researchers such as Bruce Schneier, or government agencies such as the GCHQ and the US Department of Defense. You can do all of this with the software tools we cover in our tutorials. Most such tools allow you to select which method to use, so you can choose to erase data the way Peter Gutmann would, or the way the Department of Defense does. The second warning has to do with flash storage. You need to pay attention to the type of storage medium you are using. Everything we've been discussing up to this point applies to hard drives. Hard drives, or magnetic media, are the traditional technology for storing data. But if you own a USB flash drive, or an SD card, or a solid-state drive, a popular new alternative to the hard drive, these use a different technology for storing data. They are known collectively as flash storage. Some of the secure erasure techniques above will not work on flash storage. This is because of something called wear leveling. Basically, with hard drives, you can write ones and zeros as many times as you want to any space in the hard drive, but flash storage wears out. If you were to write ones and zeros to the same space over and over again thousands of times, that space would eventually run out and go bad. And when enough spaces go bad, the drive becomes unusable. To get around this, flash storage is designed to use wear leveling. Wear leveling is a technique used to reduce wear on your media. It means that when you write data to the disk, even just new data to an old file, it uses a new space, so that the number of writes is spread out evenly over the entire disk, and no one space is overloaded. So what does this mean for secure erasure of data? It means that you can't erase individual files on a flash storage device. If you try to overwrite them, the overwrites will miss. The drive will automatically try to reduce wear by spreading your overwrites out over the rest of the drive, and the original data will be largely untouched. While the individual file erasure method works on older hard drives, it is impossible to know if your original data is overwritten on flash storage. Apple has even removed the feature of Mac OS that allowed erasure of individual files, because most Apple drives are SSDs nowadays. So if you have an SSD or a USB flash drive or memory card, what should you do? First of all, it is even more important that you use full disk encryption when you use this kind of media. And secondly, if you must erase data on them, you must erase the free space or the whole drive, rather than individual files, in order to ensure that the data is actually overwritten. And even then, even when you've erased all of the free space, or all of your SSD, there is still room for doubt that the data has been properly erased. This is because SSDs, and even more modern hard drives, use new file systems and new optimization, compression, and fault tolerance technologies, which complicate matters even further, and makes it really difficult, even for computer scientists, to know if and when data is truly erased. Because there's lots of variation among drives in how they use these technologies, there is little consensus on data remnants in SSDs and newer hard drives. So while it's certainly a good idea to securely erase everything as a precaution, it's very difficult to have any certainty that no data could ever be recovered. Here's a third warning about securely erasing data. Years ago, the only component of your computer that could remember significant amounts of information was the internal drive. This has changed in recent years. Nowadays, computers have all sorts of other components which are capable of storing information. For instance, your network card, your graphics processor, and a component called the BIOS or UEFI all have dedicated storage which allows their firmware to be updated. They can form a series of little enclaves within your computer which can retain data even when you erase the main drive. So, if you want to completely erase a computer, it may not be sufficient to erase the hard drive only, and things get a lot more technical if you want to go after these. However, the main concern with these kinds of storage is if your computer has been infected with sophisticated malware, which can try to hide in these enclaves. In a regular scenario, it is unlikely that any data from a sensitive document you're working on could wind up in one of these places. So securely erasing a computer's drive will probably deal with 99% of cases. And that more or less covers a broad overview of how to securely erase data. But what if securely erasing data isn't enough? What if you don't trust that the software does what it says it does? What if you want to completely eliminate uncertainty? In this case, there is always a fourth precaution you can take: the nuclear option. If all else fails, you can always try to physically destroy your drive. If the hard drive no longer exists, data cannot be recovered from it. Famously, when it was working on the Snowden documents, The Guardian was forced to physically destroy its own hard drives under the watchful eye of two technical experts from the GCHQ. So this is a method that is employed by intelligence agencies, and it can be assumed that it is effective. There are many commercial companies that offer services for the destruction of hard drives. This often takes the form of degaussing, using a special machine to inundate your hard drive with large amounts of electromagnetic energy, instantaneously erasing all of the data magnetically stored on it and rendering it inoperable in the process. There are also hard drive shredding services, which can smash your drive into small pieces or even into fine dust. But these can be expensive, and you may also not want to entrust a third party with drives that you would like to destroy. In this case, you may wish to perform a DIY physical destruction of your drive. Your mileage may vary, but we have included a tutorial, Destroying Your Media, demonstrating the most obvious methods for destroying computer hardware. Another thing to consider before you start using the techniques we've discussed is the legal dimension. Depending on the jurisdiction you live and work in, using any of these techniques may have legal implications. For instance, the United Kingdom has extremely regressive laws on the use of encryption, embodied in the Regulation of Investigatory Powers Act 2000. This can make it a crime to refuse to decrypt your hard drive if the police ask you to. So even just being in possession of an encrypted hard drive may be a legal liability. Furthermore, if data in your possession is subject to a criminal investigation, or might constitute evidence in such an investigation, then securely erasing that data, or physically destroying the media the data is on, may be looked upon as an obstruction of justice under the laws of your country. If you're unsure about any legal risk you may incur by employing the techniques in this tutorial, you should seek the advice of a lawyer with an understanding of the law on the use of encryption. Finally, if you're really concerned about handling data, Windows or Mac OS might not be the ideal platforms on which to do it. These operating systems have a lot of features which make life easier for the general user, but which make life a lot more difficult, or even impossible, for someone who wants to handle data securely. For example, Windows stores all sorts of backup files and logs, and it's not always obvious where they're stored. So even if you erase sensitive documents after working with them, fragments or records of them might be stored somewhere else and you mightn't even know it. Furthermore, recent versions of Windows, such as Windows 10, have a lot of privacy-invading features that essentially monitor your usage of your computer and send information about it to Microsoft. So even if you go to great lengths to erase the files, traces of them, records of them, even copies of them might be retained outside of your computer on servers in another country. Needless to say, you should turn features like that off if you're concerned about handling data securely. Turning all of these features off is beyond the scope of this tutorial, but we're including links in the description to some basic steps you can take. Our tutorials for Mac and Windows show you how to ensure that the worst kinds of data remnants are addressed. But it should be said, doing this is no substitute for thinking carefully about how you handle your data and turning off any apps that might undermine your efforts. And if you don't feel happy using Windows or Mac OS anymore, think about using a more secure operating system such as Tails or Cubes or Subgraph. Keep an eye out for tutorials on those systems in future. And that's it for this tutorial on handling data securely. It's a huge topic, and there's obviously plenty more to say about it, but that is as much as we can cover in this introduction. In the next few videos, we're going to show you how to do everything we've discussed in this tutorial on Windows and Mac. Click or tap on the pop-up message to go to one of those tutorials now. Thanks for watching Infosec Bytes. If you found this video useful, please share it widely with your colleagues and co-workers. To support the Centre for Investigative Journalism with a donation, please visit tcij.org/donate. And if you would like to watch our other videos, please go to infosecbytes.org or subscribe to our channel below.